Okay, let's get started. If someone joins the waiting room, can you guys please let me know in the chat because I won't be checking the waiting room anymore. So yeah. So in today's seminar, we're going to be covering a basic introduction to time complexity. We will be covering the 3 sorting algorithms, and we will also be learning about Python classes. There will also be some practice problems that'll give you guys time to solve at the end. And if you guys have any extra questions, there will be a Q&A session at the end. And also, if you guys have questions during the seminar, don't hesitate to ask them or offer comments and suggestions in the chat throughout the seminar. Yeah, Kehu, do you have a question right now? Because I see that you raised your hand.
Yes. I wonder where we can access to the recorded videos. Hello? Is my microphone working?
I hear your boss, but I don't hear anyone else.
Hey, sorry, Kehu, my speakers aren't really working, so if you can type the question that you have in the chat, I would appreciate that, because right now I'm not sure why my speakers are not working, but I can't really hear what you're saying. Okay, I'll get started with the actual topics in the seminar. So first, we're going to begin by talking about time complexity. So time complexity is a concept that simply refers to how fast or slow a program will take to run. In CSCA08, you were introduced to the following 3 time complexities: constant, linear, and quadratic. If you're going to be taking CSCA48 in the future, this topic will be explored in greater depth. So a function with a constant time complexity will only have loops that repeat a constant specific number of times whenever this specific number is not dependent on the values of the parameters. So in this example, we have a function called x plus y times 5, where we add x plus y 5 times. And this function has a constant runtime because the loop here only repeats itself 5 times. A function with loops that depend on the value of a parameter and don't contain any more loops nested within them have a linear runtime. So in this first example here's a function called do something that has an integer parameter called m1. So in this function, there is a for loop that goes from 0 all the way to m1 minus 1. And this function has a linear runtime. In the second example, we called the function do something again, and this time it contains a nested for loop that only runs 5 times, and it's still a linear runtime because every line within the first for loop will only be run 5 times m1, so therefore it only depends on the parameter m1. Finally, there's quadratic runtime, and the function contains a loop with linear time complexity within a loop with linear time complexity. So you can just imagine a nested for loop that is inside of another for loop, and both of them are dependent on a different integer parameter, and this has quadratic time complexity. So now we're going to be talking about sorting algorithms. So in CSCA08, you were introduced to the following sorting algorithms, which are bubble sort, insertion sort, and selection sort. Bubble sort works with sublists of different lengths from the length of the list all the way to length 2. It swaps the consecutive values starting from index 0 to the last index of the sublist, and the goal of the swapping is to put the largest value at the end of each sublist. Insertion sort works with sublists of different lengths from length 2 to the length of the list. It swaps consecutive values starting from the last index of the sublist to index 0, and the goal is to put the smallest values at the beginning of each sublist. Selection sort basically works by swapping the value stored at index I with the I plus 1 smallest value. So for example, the value stored in index 0 will be swapped with the smallest value in the list, and the value stored in index 1 will be swapped with the second smallest value, and you can just keep going on and on until you reach the end of the list. So to illustrate how these three algorithms work differently, I'm gonna use this example. So suppose we wanted to sort this list containing the numbers 14, 24, 0, and 9. So if we're using bubble sort, the first pass of bubble sort will start by comparing 14 to 24, and since 14 is smaller than 24, nothing is changed. Then we compare 24 to 0, and since 24 is larger than 0, the two values are swapped. And then it compares 24 to 9, and since 24 is larger than 9, the two values are swapped again. And then, so by doing this, we pushed 24 to the very end of the list. Then we start at index 0 again, and then we compare 14 to 0, and since 14 is larger than 0, the two values are swapped. Then we compare 14 to 9, and since 14 is less than 9, the two values are swapped again, and then we sorted this sublist of length 3 by pushing 14 to the very end of it. And then the third pass of bubble sort will try to move the largest value of the sublist 09 to the end, which is index 1 of array. So it will basically compare 0 to 9, and since 0 is less than 9, no changes are made, and now the list is sorted properly. In insertion sort, the first pass will focus on moving the smallest value of the sublist of length 2 containing 14 and 24 all the way to index 0. So it will compare 14 to 24, 24 to 14, and since 24 is larger than 14, then you don't really need to move 24 to, you don't need to swap the values, so therefore nothing changes. The second pass of insertion sort will move the smallest value inside the sublist 14, 24, and 0 to index 0 of array. So first it starts by comparing 0 to 24. And since 0 is less than 24, the values are swapped, as you can see here, and at the end of step 1. And then in step 2, we compare 0 to 14. And since 0 is less than 14, the two values are swapped. And then we have the list with 0 at the very beginning. Then in the third pass of insertion sort, the smallest value of the list 0, 14, 24, and 9 is moved towards index 0. So we first begin by comparing 9 to 24, and since 9 is less than 24, the values are swapped, and then you do more comparisons, and at the end, we end up with 9 being at the right of 0, and now the list is sorted properly. So in selection sort, we first begin by swapping the smallest value of the list with the value stored in index 0. So we begin by comparing 14 to 24, and 14 is smaller. So we can say for now 14 is the smallest. Then we compare 14 with 0, and since 0 is less than 14, 0 is now the smallest. And then we compare 0 with 9, and since 0 is less than 9, 0 is still the smallest. So therefore we swap 14 with 0 to get the list 0, 24, 14, and 9. Then the second pass will swap the second smallest value of the list with the value stored in index 1. So we begin by comparing 24 with 14. And since 14 is smaller, for now we can say 14 is the smallest. Then we compare 14 with 9, and since 9 is smaller than 14, then 9 is the smallest. So then we can swap 24 with 9. Then in the third pass, it swaps the third smallest value of the list with the value stored in index 2. So we start by comparing 14 with 24, and since 14 is smaller, we can say 14 is the smallest value, and we don't need to make any changes because it's already sorted. And now the list is sorted properly. So bubble sort does not have a best or worst case time complexity, and because it never really finishes running, even if the list is sorted, and it has to go through every item in the list. So therefore every case is the average case, and it has quadratic time complexity. Insertion sort has a best case and a worst case complexity. Its best case is linear and its worst case is quadratic. Its average case is also quadratic. Selection sort is pretty much like bubble sort. It has to go through the entire list even if the list is already sorted. So all cases are the average case, and it has a quadratic time complexity. So here is an example of a best case scenario of insertion sort. The best case scenario will be created when you pass a list that is already sorted from least to greatest into insertion sort. So an example would be just the list 1, 2, 3, 4, 5. So as you can see in the table, in the first pass, there's just one comparison comparing the number 2 to the number 1. And since the number 2 is bigger than the number 1, nothing happens. Then in the second pass, we compare the number 3 to number 2. And since the number 3 is larger than the number 2, we don't really change the list at all. And we can assume, and the algorithm just assumes that the rest of the list is just sorted. Then in the third pass, the number 4 is compared to the number 3. And since 4 is larger than 3, nothing happens. And the number 4, in pass 4, the number 5 is compared to the number 4, and since 5 is larger than 4, no changes are made, so therefore Every pass, as you can see, only has one comparison, so it has a linear time complexity. So the worst case scenario of insertion sort would be when you pass a list that is sorted from greatest to least. So an example here would be the list 5, 4, 3, 2, 1. So in the first pass, you would compare the number 4 to number 5, and since 4 is less than 5, you would swap the two. Then in the second pass, you would first compare the number 3 to number 5, and since 3 is less than 5, you would swap them. Then you would compare 3 to 4, and since 3 is less than 4, you would swap them again. Then in the third pass, you would compare 2 to 5, and since 2 is less than 5, then you swap them. And then you would compare the number 2 to number 4, and since 2 is less than 4, then you would swap them. Then you would compare the number 2 to number 3, and since 2 is less than 3, then you would just swap it again. Then for the fourth pass, you would make a comparison between 1 and every other number in the list, and since 1 is smaller than all the other numbers, you would perform 4 swaps. And this is the worst case of insertion sort because every pass has a completely different number of comparisons, and therefore it would result in a quadratic runtime. So I wrote some code for insertion for all three sorting algorithms that I can explain briefly here. You can just scan this QR code. I'll give you like 30 seconds to scan the QR code if you want to just look at it on your phone, and then I will click on the link and then go to it. Okay, okay, can you guys see what is on my screen? Or do you guys need me to zoom in more? Because I remember in the second seminar, the test 2 seminar, there were issues with seeing the screen when it came to this program. Okay, I will start explaining this. So in bubble sort, we basically have a outer for loop going from 0 all the way to the length of the list minus 1 because you don't, for the last element of the list, there is nothing to compare it with. So and then there's an inner nested for loop going from 0 all the way till the length of the array minus I minus 1 because this is how we begin working with like sub lists because after the largest value is moved to the end of the list, you want to work with a smaller sub list so that you can continue by moving the largest value of each sublist to the end of the sublist only. You don't want to affect values that are already sorted. Then it checks if the array at a certain index called j is bigger than the one to the right of it. And if it is, then we perform a swap. And this just keeps repeating all the way until the list is sorted. Then in insertion sort, we have a for loop going from 0 all the way to the length of the array minus 1. And then inside of this for loop, we have an inner for loop going from I plus 1 all the way down to 0, and it decreases by 1 each time because we only want to work with work with a sublist going from I+1 all the way to 0. Then we check if the array at index j is smaller than the value in the index to the left of it. And if it is, then we swap the two values because we're trying to push the smallest value all the way to the index 0 of the array. So for selection sort, I wrote this helper function called get index of I smallest, which basically just returns the ith smallest value. So it takes a list of integers and a value I, which is an integer, and returns an integer. So we start by assigning the value result with -1. And if I is less than the length of the array, -1, and if I is bigger than -1, which means that I is a valid value, then we can continue with finding the smallest value in the array. If we passed in a value of I that was, say, negative or like bigger than the actual length of the list, then we can't really actually look for the ith smallest value. So then we would just return -1 here. But if we continue looking for the ith smallest value, then we start by saying result equals I. Then we go through every value in the array starting from I+1 all the way to the end. Then we compare the array, the difference of the array at I minus the array at j with the difference between the array at I minus array at result. And if array at I minus array at j is larger than array at I minus array at result, then the result would equal, then you would just change the result to j. Then you would keep repeating this until you reach at the end of the list, and then you would just return the result. Then in our selection sort program function, we have a for loop going from the length of the array going from 0 all the way to the length of array -1. And then we get the index of the ith smallest by calling the helper function that we wrote. And then if n does not equal -1, and if n does not equal I, then we would say that then we would perform a swap. So this version of the code just doesn't, I did change this code to fix the mistakes of this version, but I'm not really sure why the URL led to this paste bin, because I did create another one. So I will update the slides with the one that is actually correct, because this is not the most correct way of actually doing this code, but I'm not really sure what happened when I last updated it and now. So forgive me on that, but I will post the updated slides at the end of the seminar. So now we will talk about classes. So in Python, everything is an object. And objects can be represented with a structure called a class. A class provides a constructor for creating objects with different properties and methods that can perform some tasks using the object's properties. And the instance of a class can be represented with the word self within the class. A function that can be used to create a new instance of an object with properties initialized with the properties initial. So this would be the init function. And every class can only have up to one constructor, but you can allow the parameters to be optional. So here's an example. I wrote a class called something, and it just has the init function with the parameters self, prop1, prop2, and prop3, but you can add as many or as little props as you would like. And I made all three of these props optional by by defaulting them to the value 0. And then the init function usually returns none. And then I would say self.prop1 equals prop1, and then continue assigning all of the props to the class. So then you can use special operators on objects. So the examples of these operators would be the Boolean double equals, or adding, subtracting, bigger than, less than, length, the length function to check its length, the string function, and the print function. And when these operators are used with an object with a defined class, it will call a predefined method. And these predefined methods can be customized and overwritten, but you must write the method's signature with double underscores. So the method EQ with 2 parameters, self and other, would be called when you use the Boolean double equals check sign to determine whether 2 objects are equal. The string method would be called when you call the string method with the double underscores will be called when you call the string method or the print method outside of the class. The length method with the double underscores will be called when you call the length method outside of the class declaration. Then the add method with 2 parameters and the double underscores will be called when you use the plus sign for self and the for 2 objects of the same type. Sub would be the same thing as add, except it's for subtraction. And then LT would be will determine whether self is less than other, which are just 2 objects of the same type. So it will be called when self is less than other, when you want to compare to see whether self is less than other. And then GT stands for greater than, and it will compare the 2 parameters, self and other. And you would basically, it will be called when you use the greater than parameter to determine whether self is greater than other. So a class can inherit the properties and the methods of another class. The class it inherits from is called a parent, and this class can be called a child. Python allows each class to inherit from many other classes. In other words, every child can have many parents. So when you implement inheritance, the child class must be declared with the following format. Class child, and then in brackets you put the parent. The class name of the parent. So here child 1 inherits all the methods from parent 1. You can also have child 1 inherit from multiple parents by declaring child 1 as class child 1 and then put all the parents in a comma separated list in brackets. The constructor of child 1 must contain one of the following lines. So it will either be, you would use the word super with brackets, and then you would use dot, and then you would use the double underscore method init, and then you would put a comma separated list of all of self, and then followed by all the properties. But you can't use this if there's more than one parent. And then you can just use you would put the name of the parent class and then followed by a dot and then followed by the double underscore init method, and then you would put the parameters as self followed by all the properties that the parent can take. And child 1 can override any methods in its parents' classes. So I wrote an example here. So number is a class that can store a float value for further comparisons and calculations. It also contains methods that can be called when the operators plus, minus, less than, greater than, the Boolean equals check, and string are used. String returns the float value as a string. Fraction is a class whose internal representation contains 2 integers, one for the fraction's numerator and one for the fraction's denominator. It extends the number class and it overrides the implementations of string add and sub methods from the number class. The implementation of add and sub return a fraction instead of a number object. Square root is a class whose internal representation contains a float value representing the input value for the square root function. It extends the number class and it overrides the implementation of the double underscore string method from the number class. So you guys can like scan this QR code if you want to look at the thing that I wrote using your phone, and then I will click on this link in like 30 seconds. Okay, so then I first begin by importing the math library, which is a library that comes bundled with Python 3 by default. Then I create the class number. It should have a header, but I forgot to put that there. Then I create the constructor, which begins by creating a number with a float value. So in the docstring example, we would have num1 equals number 0.938459345. And then when you type in num1.value, it would just return its value over here. So simply all you have to do is use self.value equals x. Then we would have to overwrite the implementation of the double underscore string method. So in the docstring, it just says that the string method returns the string representation of this number's float value. So we create that really long decimal number again. And then when we call the string method on num1, it should return the value of that really long decimal number, but in quotes. And simply all you would do here is call the string method on the self.value, which is a float. Then to implement the double underscore EQ method, first I begin by writing a docstring that says the function determines whether the two numbers are equal by comparing their values. Then I write that. So then in the docstring examples, we have num1 equals the number with that really long decimal number. And then num2 would be a number with the value of 0.5. So we should get num1 equals num1. We should get the result true when we test whether num1 equals num1. But when testing whether num2 equals num1, we should get false. And simply all you would do is type in over here determine whether self.value is the same as other.value by using the Boolean double equal signs. Then for LT, it determines whether the two numbers are less than each other based on their values. So num1 is just a number with a value of 6.00. Num2 is a number with a value 5.00, and num3 is the number with the value 5.00. So num2 less than num1, we should expect it to be true. Num2 less than num2 should be false because they're both the same value, and num2 less than num3 should also be false because they're all the same value. So simply you would just use the less than operator on the value property of self and other. Then you would check. Then for the GT with the double underscore function, with two parameters, self and other, it determines whether the two numbers are greater than each other based on their values. So then we have the same three numbers from the LT method. So then when comparing num1 to num2, and to determine whether num1 is greater, we should expect it to be true because 6 is greater than 5. then num2 greater than num2, we should expect it to be false because they are equal. And then num3 bigger than num3, we expect it to be false because they're equal. Then you would simply just compare the self.value property with the other dot value property using the greater than sign. Then to implement the add method, you would simply return a new number with containing a new value of the sum of self.value and other.value. This line 85 over here should say add and not int. Like it should. Never mind. It's actually correct. So when this line 85 over here, when it says int num1 plus num2, it would return a number. It will return a new number object, but then when you cast it to it should say float, not int, but I think I have to edit this because this line 85 should say like num1 dot num2 dot value, and then it should equal 1.6. So I'm going to type in what line 85 should actually be in the chat because that is wrong. I'm not really sure why the chat wasn't loading, but while I was doing the presentation, but you guys were participating a lot in the chat and I didn't really even notice, which is my fault. But I'm gonna check through the chat to see if there was any questions that was asked or if there's anything notable that was ever said. Because I'm not really sure why the chat was not loading while I was talking, because only now I'm seeing all this cool stuff you guys are saying. Okay, so the recording will be posted on the Piazza and the Discord when after the seminar is over. I do have to edit the slides because there was an extra Piazza question that I did not put in the slides right now that I have to still talk about at the end of my presentation. So I have to edit the slides to include that, but I will definitely try to upload those to the Piazza a few hours after the seminar ends, because last time for test 2 it took like about like an hour or so to like download the recording. So the Discord for the AMAS community Discord, I can put a link in the chat. You can go to amas.org and then click on the Discord button right over here, but I can totally put in the chat for you guys. Also, if you guys still have questions about this seminar, like after the seminar is over, you can also just go back to the announcement that I made for the seminar and just ask it there, and I will try to answer the questions. Because your exam is tomorrow at is it tomorrow at 1 p.m.? Okay. Okay, so I'm gonna go back to talking about this. So, the subtract method, line 101 has the same problem as line 85 of the add method. So I will have to go and change that and update the example. But simply you would just return a number with the value, with the difference between self.value and other.value. Then for the fraction class, you would create the constructor by using super and then the constructor for the parent, and then the value would be the float of the numerator divided by the float of the denominator. Then you would contain an internal then this method would this class would contain an internal representation of the numerator and the denominator. So you would just use self.num equals num and self.den equals den, num for numerator and den for denominator. Then for the double underscore string method, you would use self.num plus that / character plus string.self.den to represent the value of the fraction in fraction format and not really decimal format. Then for the add method, you would just return a new fraction where the numerator is self.num times the other denominator plus the self.denominator times the other numerator, and the denominator is the product between self and others denominators. And then for subtract, it's pretty much the same as add, except the numerator would be the difference between self.num times other.den and self.den times other.num. Then for square root, we would have the constructor that accepts the input number, which is a float, and you would use super the super constructor to initialize the parent with the float value, and then you would use mat.square root input number to get the float value of square root, and then you would use self.input number equals input number. And then for the double underscore string method, you would return a string in the form of that square root character followed by the input number. So you would just go by putting that square root character, and then you would add string self.input number. Okay, so now we have some practice problems, but I feel like I should give you guys like 5-minute break before I get to them. So maybe we should do you guys want to come back at 5:01 or 5:05? Okay, so we can just take a break now and come back at 5:05 p.m. and then we will go through a bunch of practice problems. Yeah, I'm not really sure why I can't access the chat, but I'm not sure if I have to leave the meeting in order to access the chat again, because right now I'm having a hard time accessing the chat. I'm not really sure where it went, and now it's just gone. Okay, never mind. I got the chat back, so I don't have to leave anymore. Okay, so we can continue with the examples, and I'll share my screen again, and it's still recording, so I need to get the chat window up on my screen before I can continue with this presentation because I don't know what happened to it. Okay. Okay, so now we can continue with the first practice problem. This was a PCR problem. Somebody asked a question about it, and I didn't really understand this problem what this problem was even asking when I first saw the question on Piazza. But it basically says, consider this list and what is the maximum number of passes of selection sort that could have been completed? So you guys can just answer this question in the chat. Like this was pulled directly from your PCR material. I didn't really understand what this question was saying because I thought the exact same thing as what the person who asked the question on Piazza was thinking, and I only really understood the other explanation when I actually thought through it more. Okay, and as you can see, the solution is 2 because the first 2 indexes contain the smallest numbers in this list. So this means that either the 2 numbers were swapped or the list could have been arranged this way before passing it through selection sort, which means none of the numbers or one of the numbers could have been swapped as well. So I thought it was 5 passes because I was counting the number of passes and swaps that selection sort had left in order to actually finish sorting the array, but then I realized that this question was not asking for that. It was asking how many passes of selection sort could have been completed so far and not how many are needed to actually finish sorting the entire array. So if this question was asking how many passes of selection sort were needed to finish sorting this entire array, then it would have been 5. But yeah, I just wanted to put that here because somebody asked this on the Piazza. So for the next question, we want to consider this list containing the numbers 9, 8, 5, 10, 3, 4, 2, and 7. So this is the list after the first and second passes of a sorting algorithm. So after the first pass, the list order would be 2, 8, 5, 10, 3, 4, 9, and 7. And then after the second pass, it would be 2, 3, 5, 10, 8, 4, 9, and 7. So part A is asking which sorting algorithm is being executed here, and what will the list look like after the third pass? So I'll give you guys like 2 minutes to answer the question. Okay, so the solution to this problem is that it's selection sort, and then after the after the third pass, the list will contain the values in order 2, 3, 4, 10, 8, 5, 9, and 7 because the 4 was swapped with the 5. So a lot of you guys in the chat, I see that you got it correct. So you guys can applaud yourselves. That was really good work. Okay, so back to question 1. If I can go back to it. Okay, basically question 1 was asking how many passes of selection sort were completed on the array so far, right? So since you can see that that index 0 contains the smallest value, which is 3, and then index 1 contains the second smallest value, which also happens to be 3, you can say that since only 2 indexes, and then index 3 contains 6, which is larger than 4 and 5, you can say that only 2 passes of selection sort were completed because only the first 2 indexes contain properly sorted values, which are the 2 smallest values. This question is not asking how many how many passes of selection sort are left to completely sort the array. It's asking how many passes have already been completed and what's the maximum number. So, I mean, it could be 1, it could be 0, but the maximum number is 2. Okay, so now I'm gonna move on to question 3. So this is a really long question, so I'm gonna give you guys like a few minutes to answer each part, and then I'm going to reveal the answers to all the parts at the end. So to begin, in this question, you will complete some doc strings and write method bodies in the classes to represent bridge and highway data. So here's the header and doc string for class bridge. So it has that header. So part A says to complete the body of this method of class bridge according to the doc string. So the doc string for the constructor, for this init method, which is the constructor, the parameters of this method contains a string called name and a list of floats called span list, and it returns none. And then it the doc string says to initialize a bridge with name and spans from span list. So the example would be to create a bridge with the name CNR subway and the span list containing the values 13.1, 10.5, and 11.2. And then when you run b.name, it will return CNR subway. And then when you run b.spans, it will return that list. So I'll give you guys like 1 minute to implement the body. Okay, so you would basically, I'm not supposed to reveal the answer just yet. So for the next part, you would want to complete the body of this method of the class bridge according to the docstring. So the method is called extend bridge, and it contains the parameters, a float parameter called new span, and a Boolean parameter called add start, and then it returns nothing. So it updates the bridge to include a new span described by the variable new span at either the start or the end of the list of spans according to the value of at start. So the docstring example, you create a new bridge called B with the name CNR subway and the span list 13.1, 10.5, and 11.2. Then you would use the B dot extend bridge, and then you would the parameters would the arguments you would pass would be 5.5 and true. Then when you run b dot spans, you would see that 5.5 was added at the beginning of the span list. If you extend bridge and pass the parameters 8.8 and false, and then you run b dot spans, you should see that 8.8 is added at the end because at start was false. So I'll give you guys 1 minute to implement this function. Okay, Okay, I'm gonna move on to the next part of the question. So basically this next part says complete the body of the class bridge, the double underscore EQ method according to the docstring. So use the provided class bridge helper method, get length in your solutions. So yeah, that semicolon followed by the period is not supposed to be there, but so I'll have to edit it out at the end of the seminar. So you can assume that the get length function has been implemented according to its docstring. So the get length function returns a float and it returns the total length of the spans in this bridge. So for example, if you create a new bridge with the name CNR subway and then a span list containing the numbers 1.5, 1.5, and 1.0, and then you call get length on B, you should expect the value 4.0 because 1.5 plus 1.5 plus 1.0 equals 4.0. But your job is not to implement get length, it is to implement the second function, the double underscore EQ, which accepts which accepts a bridge parameter called other and returns a Boolean value. So basically it returns true if and only if this bridge has the same name and length as other. So if we create two bridges, B1 equals CNR subway and contains the span list 1.5, 1.5, and 1.0. Bridge 2 is also named CNR subway and contains the values 1.0, 1.0, and 2.0. And then if you compare B1 equals B2 using the Boolean equals checking operator, then it should return true. And then B3 equals, you create a new bridge called B3 with the name CNR subway and the span list 1.0, 1.0, and 2.5. And if you use the Boolean double equals operator, comparing B1 and B3, you should get false because B1 is not equal to B3. So I'll give you guys maybe a minute to implement this. Okay, so I was busy trying to respond to people in the chat, so I hope you guys took the time to attempt part C. So we're now going to move on to part D. So now consider the class highway, and this is the header and doc string for class highway. So part D says complete the body of this method of class highway according to the doc string. So this method is just the constructor. It takes a parameter called an integer parameter called hw underscore number. It takes a string parameter called region and returns nothing. So the doc string says to initialize a highway with highway number hw underscore number that begins in region. This new highway should have length 0 and no bridges. So in this example, in the doc string example, we create a new highway with the number 400 and the region Toronto. And then when you run h dot number, it should result in 400, and then h dot regions should have an array with the region Toronto in it, because that's how you initialized it. Then when you run h dot length, it should return 0.0, and then when you run h dot bridges, it should return an empty list. So I'll give you guys like about a minute to implement just the body of the function, and then we'll move on to part E. Okay, so for part E, again, you're completing the doc string of the class highway method add underscore bridge according to the function body. You can assume that the method extend underscore highway has been implemented according to its doc string. So extend highway has a float parameter called extension underscore len and a list of strings parameter called new underscore regions and returns nothing. The doc string says that extend underscore highway updates this highway by increasing its length by extension underscore length and appending any regions from new regions that are not already in its region list in the same order that as they appear in new regions. So in the example, you create a new highway with the number 400 and the region Toronto, and then you extend the highway by the length 50.5, and then you would add the new regions Toronto and York, and then h dot length would be 50.5, and h dot regions would contain Toronto and York. And you have to notice that Toronto is not repeated twice. So even if you add a region twice, it should only appear once. So then if you extend the highway by extension length 20.1, and then you add the new regions Simcoe and York, then you would, and then you go h dot length, then you should get 70.6 because 50.5 plus 20.1 equals 70.6. And then if you run h.regions, it should include Toronto, York, and Simcoe. But you don't have to implement this function. You just need to use it for the add bridge function. So then in the add bridge function, basically it says update this highway by adding a new bridge to it in the doc string. So the add bridge function contains a bridge parameter called new underscore bridge and a string parameter called bridge underscore region. And so in the docstring example, you create a new bridge B with the name CNR subway and the span list containing the values 1.1, 2.2, and 3.3. And then you create a new highway with the number 403 and then the region Oxford. Then you add the bridge B and then with the region Brant. So when you run h.length, you would want to, I just need you guys to write down what would be the expected outcome, and then for h.regions, what would be the expected outcome. So then in the function body, it appends the new bridge to the list of bridges, and then it extends the highway by the length of the new bridge and a list containing the bridge region name. So I'll give you guys about 1 minute to implement to fill in those 2 lines of the doc string. Okay, so I'm gonna move on to the last part of question 3, which is part F. Wait. Not sure why it's labeled with part B, but it's supposed to be part F. And it basically says complete the body of this method of the class highway according to the doc string. So it's just the double underscore string method, and it returns the string representation of this highway. So in the doc string example, we create a new highway H with the number 403 and the region Oxford. Then we add the bridge with the name CNR subway and the span list 1.1, 2.2, and 3.3. And then we add it in a region called Brant. Then we add the bridge with the name Thames River and then with the span list 5.0, 5.0. And then for the region, we say it's in Oxford. Then if we call print on the highway H, it would say highway 403 has 2 bridges with total length 16.6 because the sum of the length of the first bridge and the second bridge is 16.6. And then it would list the bridges by saying the bridges are, and then it would list the bridges followed by a new line. So every bridge is separated by a new line. So you guys can I'll give you guys a minute to implement the function body. You guys can type it in the chat if you guys want. And then after this part, I will go through all the answers of all the 6 parts of question 3. Okay, so I'll give you guys maybe 30 seconds to scan that QR code if you want to look at the answer by yourself on your phone. And then I would just click on the link and then explain the solution to each part of the question. I will repeat each part's instructions from the beginning because I think that since I didn't really take up the answer of each part immediately after I gave you guys the chance to work on it, that you guys just forgot what the instructions were. So I'll try to review it again. Okay, so to begin, part A was asking you to implement the the constructor for the class bridge. So I just copied the doc string into this file, as you can see. And basically all you would do is, since it wants you to initialize a bridge with the name and the spans from span list, all you would do is type in below the doc string, type in self.name equals name, which is the parameter name, and then self.spans equals the span list from the parameter. And by doing this, you initialize the properties name and spans. Then part B was asking you to implement the body of the function of extend bridge. So basically, this function should update the bridge to include So the docstring says to update the bridge to include a new span at either the start or the end of the list of spans, according to the value of the parameter at underscore start. So basically, you would just check if at start is true, and if it is, you would put the new span at the start. So basically, how I implemented it was created a list with the value of new span and then joined it with the list self.spans. And if at start is false, then you would use self.spans append new span to add it at the end. So someone in the chat told me that you can also use the insert method on line 29. So another possible solution could be self.spans and then insert. I am typing in the chat as I'm speaking. You would insert the new span at the specific index. At the index 0 in yeah, so if you did this for line, whatever I wrote in line 29, then that I think would also be acceptable as well, because it inserts new span at the beginning. So then part C, wants you to implement the equals function, and the way I did it was incorrect because I did not check the name. I did not write any code checking the names of the two bridges. So the answer should be return self dot name equals other dot name, and self dot get length equals other dot get length. That is actually that is like the actual answer. So if you guys typed in that, then you guys did a good job, and don't follow what I wrote there, because if you wrote what I wrote there, it would be wrong. Okay, so part D asks you to complete the body of the constructor for the class highway. So since it says in the doc string that the constructor initializes a highway with highway number HW underscore number that begins in region. This new highway should have a length of 0 and no bridges. So basically, you would create a property number by using self.number and then assign it the value HW underscore number. Then self.regions should equal a list containing the value of region. So this answer in line 78 over here is completely fine. Then self.length should equal 0.0 because it says in the doc string, and self.bridges should be an empty list. Then part E was asking you to implement the body of add bridge. And the doc string of add bridge says to update this highway by adding a new bridge to it. No, it wasn't asking you to implement the body. It was asking you to finish implementing the doc string. So I wanted you to write down the results of h.length. So that would be 4.0 here because 1.5 plus 1.5 plus 1.0 would be 4.0, and that is the span list of the bridge B, and 4.0 is the length of bridge B. H dot regions should be, it should be an array called Oxford and Brand, so it shouldn't just be Brand, it should be Oxford, and a list containing Oxford and then followed by Brand. And not just Brand. So if you wrote whatever I wrote in the chat, then that would be correct. Yeah, they are supposed to be 1.1, 2.2, and 3.3. I don't know why I did not copy it properly. Yeah, there's a lot of mistakes in my slides. So what I'm thinking is that I would post the slides right after the seminar with the mistakes, and then I would quickly update the mistakes after and then update it so that you guys can have like something without mistakes to actually learn from and study from. Okay, so the final part, which is part F, asked you to implement the body of the string method. So the string method should say highway followed by the number has blank bridges, which is like the number of bridges it has, with total length followed by the length, and then you would say the bridges are followed by a new line, and then you would list the bridges separated by a new line. So basically, I just created a variable called results and assigned it with the string highway 403 has, and then I convert the length of the bridges property from an integer to a string to concatenate it with the string, and then I continue with the string with total length, and then I convert the length property to a string, and then I concatenate the string, the bridges are followed by the colon followed by the new line, and then for every bridge in self.bridges, you want to concatenate the bridge name to result and then separate it with a new line. Then I return the result from 0 all the way to the second last character because I want to remove the last new line character, because in the doc string it's not like followed. Thames River, it's not followed by a new line character. So that's what I did here to implement the string method. muted the entire time. So would you guys like me to explain the answers again, or do you want me to just move on to the next question? Okay. Since a lot of the code that I wrote here did have a bunch of mistakes, so I'm going to update whatever I wrote on the slides to fix the mistakes and try to give you guys something with as little mistakes as possible as soon as I can. Mm, yes. Okay, so for question 4, it's basically saying, suppose we define this string variable xs equals the string with the characters 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's basically asking which of the following would produce an empty string. So the first option would be xs with the indexing starting from index 2, going up to but not including index 7, and then it skips 5 characters each time. Or the second option would be xs with the indexing the second last character followed by the seventh all the way to the seventh last character, going by every character, and it goes backwards. The third one would be you would first do a slice going from 2 to 7, index 2 to index 6, and then make it go from don't skip any of the characters, and then you would slice whatever you sliced again, going from the fourth character, and then part D would be XS, the XS variable going from the character at index 4 going to the character in the fifth last index, and then skipping and then going backwards, not skipping any of the characters. Or part E, none of the above. So I'll give you guys like a minute or two to try to answer this one. You guys can type it out in the chat when you're ready. Okay, I will reveal the answer right now. So the solution is D, because the output of the code in option A is 2, because it starts at index 2, which is, if you count 0, 1, 2, which is the character 2, and then it should end at index 6, which is the number 6, but then it skips 5 characters, so it skips 5 characters, so it will only contain the number 2. So the output of option B goes from the second last character all the way to the 7th last character, and then it goes backwards but doesn't skip any of the characters. So the 7th last character would be the number 7 over here, and then the second last character would be the number 8, and then the 7th last character would be, if you start counting, 7 would be -3, 6 would be -4, 5 would be -5, 4 would be -6, and 3 would be -7. So it does not include the number 3. So it goes from 8 all the way to 4. So then it would just create the string 8, 7, 6, 5, 4. So then part C starts by slicing the string XS by going from index 2, which would be the number 2, all the way to the index 6, which would be 2, 3, 4, 5, 6. And then you slice it again by going from index 4 of that string. So if the number 2 is index 0, then index 4 would be 1, 2, 3, 4. So then it would be the number 6. And then it goes all the way up to index 5, and then doesn't skip any characters, but then there's no index 5. So then this contains the value of 6, and then the output of D, it starts at index 4, which is the number 4, and then it goes all the way to the 5th last index. So if you count from 9, so 9 is -1, 8 is -2, 7 is -3, 6 is -4, and 5 is -5, but then you don't include the 5th last index, and then you go backwards. So technically, these should contain 4. Yeah, going backwards technically should not work, probably. So that's why the answer is D, and not the other ones. Okay, so this is the last question. I know it's like 6 o'clock, so if you guys want to stay, you can, or you guys are also free to go if you would like. But after this question, someone on Piazza asked about question 8 on the 2016 final exam, so I would like to at least attempt that on online GDB or something like that. So you guys are free to leave if you want, but you guys can also stay as well. So for question 5, it says consider this following class, and it just says a first in first out FIFO queue, and it contains the constructor method, it contains the method is empty, and then it contains 2 methods, on queue and dequeue. So you guys can look through it yourselves, and then I'll give you guys a minute for you guys to look through it yourselves, and then I'll move on to the next slide because it has the question on it. Okay, so for question 5, I'm gonna move on to the next part. So it basically is asking, briefly explain what is wrong with the code on the previous page and what the ramifications are for the different problems. And then part B says to explain how to repair the code. You don't need to rewrite everything. You can say things like change the arrows in the type contracts from an arrow with a single dash to an arrow with a double dash, but that's obviously not going to do anything. But if you are adding any code comments or doc strings, you should write out fully what is to be added. So for part A, I'll let you guys look at the code again, the previous slide. And then you guys can like answer in the chat what you guys think is wrong with the implementation of the class Q. Okay, so you guys can also answer part B in the chat. So basically you would just say what lines you would change in this implementation of the class Q. So you guys can just type out like the edited line, and I think I'll be able to understand which line you're referring to. Okay, so the solution for this is so for part A, the solution is the enqueue function adds the item to the beginning of the list, and it doesn't follow the docstring because it's supposed to add the new item to the end of the list, according to the docstring. And the dequeue function removes the item at the very end of the list instead of the very beginning, and therefore it doesn't follow its docstring. So those are the two main issues with the code. Then in part B, you can say that the onQueue function should return self.items plus a list containing the value new item, and the dequeue function should return and remove self.items at index 0 instead of index -1. So if you remember going back to the dequeue function, the return item is the item at the very last index, and then it returns, and then it sets the items to self.items going from index 0 all the way to the second last character, and then it returns the last item, but it should be returning self.items at 0, and it should also be removing setting self.items equals should be equaling self.items from index 1 all the way to the end instead of the beginning all the way to the second last character. So those are the two lines you should fix in the dequeue function, and then you can just return the beginning, the first item in the list. So that is all that I prepared, but someone on Piazza did ask about the 2016 exam for question 8, which was the one with the Shakespeare play, and reading the file containing the play lines. So I'm gonna go on the Piazza and go through that question right now. Because somebody did send a screenshot. So it says in a play, the lines each character speaks have the following format. So it has square brackets with the character name, and then it says first line of the dialogue and followed by a tab and additional lines of dialogue, and there can be 0 or more. So a file representing a play will contain a character dialogue formatted as above. So here's an example from Shakespeare's Antony and Cleopatra, and as you can see, each character either has one line of dialogue, or if they have multiple lines, there's a line followed by a new line character, followed by a tab, and then each new line is followed by a tab, and then there's a new line character to separate all the lines. So in this question, you write a function that reads a file containing the lines from the play in this format. So you can assume that the square brackets are never used except to mark a character name, and that character names may be any case, but will have consistent case throughout the file. Thirdly, there are no blank lines, and fourthly, there will always be a non-empty first line of dialogue. So on the following page, it asks you to complete the body of the function according to the docstring. Your solution should be general and work for any play file that has the format described above. You must use the existing starting code in your solution. And it says to assume the play.txt file referred to in the docstring is the example file above, which is basically the one with Antony and Cleopatra by Shakespeare. So here we have the read lines function, the doc string of the function that you have to implement. And basically, the parameters of this function are a file called play and a string called character, and it returns a list of strings. And it returns a list of the dialogues, which all the new lines removed, made by a character in the play. So it says the file. So if you open a file called play.txt, and then you can say assign the output of read lines of the file and mark Anthony to actual. So the expected would be a list of all of Mark Anthony's lines from over here. So you would expect to see something, you would expect to see, I'm sorry to give breeding to my purpose. And now my dearest queen, and what's the matter as the result. So what I just said is the expected value of actual. And then when you run actual equals expected with the Boolean checking equals, it returns true, and then you close the file. So you begin by saying, so basically the person was asking me to talk about these read file type of questions. And he said he doesn't understand why the line and this square bracket character not in line is in the solution. So I'm gonna go through the solution really quickly. I'm not sure if you guys can see the solution properly because I can't zoom in any further using my browser as an image viewer, and I think I can download the image and then try to view it. Okay, so I'm trying to change which window is being shared, but okay, so even though I zoomed in, it's really pixelated. So I hope you guys don't mind, but okay, so for the on queue and the DQ question, the front of the queue is basically the value stored in index 0 of the list, because we were using a list to implement the collection of items in the queue. And then the rear is basically the items stored at the very last index of the list. So for question 8, it says, the solution basically says while line, and then the question starts with declaring a variable called result and then assigning it with an empty array. Then it says read the first line, which includes the character's name and the first line of the string. So the line basically equals play.readline.strip. So basically what that does is it strips the beginning of the string and the end of the line of any like extra white space characters or that might have been read, or like tab characters. So then while line basically is a loop that that keeps running while the line actually contains a value and is not null or none. So basically, you would get name equals line going from index 1 all the way to line dot find the closing square bracket, because index 1 contains the first character of the person's name, and then line dot find of the closing square bracket returns the index of that closing square bracket. So the last character that is included in name should be the last character of the speaker's name. And then dialogue starts from line dot find the closing square bracket plus 2, because there is a white space character and a colon character to determine who is speaking. So you want to exclude those from the dialogue, and then it goes all the way to the end of the line. Then you would try to read the line again and then strip it of any extra like white space characters at the beginning and the end of the line. So that's basically what it does. Then it says while line is not empty, which is basically or not null, and the closing square bracket is not in the line, because if the closing square bracket is in the line, then or I'm answering a question in the chat. Okay, back to explaining this. So if the closing square bracket is not in the line, it means that you haven't really encountered a new speaker. So that means that the current speaker is still talking and they have a dialogue with more than one line. So you would just concatenate the dialogue as space followed by the line, and then you would read the line again, and you would keep reading the line until the line is not empty and it does not contain that closing square bracket character, because if it does, then it indicates that someone new is speaking. So if it does contain that square bracket character, you can append, then that loop will break out. And basically it would say if name equals the character, which was the parameter of the character you wanted the lines of, then you would append the dialogue to the result. And then you would return the result after you finish going through the entire text file. Okay, going back to question 5, it wasn't that the doc string was wrong, it's just that like the way that the person wrote the function body, it just did not follow the doc string. So the doc string was not wrong, it's just that the way that the function body was written, it just did not follow the doc string, because in the onQ function, the function body added the item to the beginning, and the DQ function removed the last item instead of the first item, but the onQ function was supposed to add the item to the end and not the beginning. So that's the mistake. And it's not really that the doc string was wrong. Okay, so is my explanation of the answer to question 8 from the 2016 exam like really clear? Or is there other parts that were confusing? Mm, so when you're asking, yeah, the return results should be outside the while loop, and I'm not really sure why it's in the while loop, so I guess I have to take note of that. But I did not write this answer, so you did bring up a good point, so thanks for mentioning that. So basically the second while loop, basically, in order for it to run, it requires that the line is not null, and it also requires that the the closing square bracket character is not in line, because if it is in line, then it indicates that the line contains the dialogue of a different character. And you only want to include like all the lines of like one dialogue at a given time, because if you remember the play file, mm, if you remember the play file, it basically it had like a person speaking, and the person can have like multiple lines of dialogue, and then when a new person's speaking, then there would be the square brackets again. And you only want to include all the dialogue from one given line of a person speaking. So that's basically why that Boolean statement is there. So when it says while line, it means the line is not empty. I think it's more like line does not equal none. But I'm not really sure if line being non-empty would actually make the result be false. So I'm actually gonna try that. Okay, so even if the line is empty, like it would still equal the Boolean statement while line would still return true, but basically when line reaches the end of the play.txt file, then while line will the Boolean statement checking for line would be false. So it's basically just checking whether line has reached the end of the file or not. And another question says, what if the first line isn't the character we want the dialogue from? So basically, as you can see below the second while loop, like after you're done implementing it, it has a comment that says now that the line has a square bracket, and so we can append as appropriate and then continue. So then it says if name equals character, because character was the parameter of type string, and it basically is indicating what characters lines you want in the result. So if the person's if the speaker's name equals the character, then you would want to append the whatever their dialogue was, and that is just one single line of dialogue into the result array. Okay, so I did notice that just right before the exam, somebody asked about the 2016 final, I think it was question 5, the one with that table where it was like with the sorting algorithms. So I'm going to load that up really quick. The person was asking on the Piazza. I'm gonna look at it real quick. But they found the bubble sort part to be really confusing, so I'm gonna go through the screenshot of the question and then try to answer it right now. Okay, so basically it says for this question 5, it says consider the following list. For each list and each algorithm, consider whether it's possible that 2 passes of the algorithm could have been completed on the list, and check the box corresponding to the algorithm if the list is a possible result of 2 passes of the algorithm. So for the first list, the reason why it's possible that 2 passes of bubble sort could have happened is because, as you can see, the last index contains the number 8, and the second last index contains the number 7, and the number 8 is the largest value, and the number 7 is the second largest value. So if you remember bubble sort, it pushes the largest values all the way to, as you know, as large of an index as possible. So since like the number 8 is sorted in the last index and the number 7 is sorted in the second last index and they're sorted properly, then it's a possible result of 2 passes of the algorithm. If, for example, if the first list originally started off as, for example, the list like 7, maybe 8, 7, 3, 3, 1, 2, then during the first pass, it would be swapping 8 with 7, and then 8 with 3, and then 8 with 3, and then 8 with 1, and then 8 with 2. So that's the first pass. No, it wouldn't be this because maybe, okay, whatever I was saying before was incorrect. So ignore that, but let's just say the list in the first part was had the values 1, 2, 3, 3, 1, 2, 3, 7, 3, and 8. No, 7, 1, 2, 3, 8, 7, 3. So then the first pass of bubble sort would swap 8 with 7 and then 8 with 3, and then the second swap of bubble sort would be swapping 7 with 3. So after the first pass of bubble sort, you would get the list 1, 2, 3, 7, 3, and 8. And then after the second one, you would be getting 1, 2, 3, 3, 7, and 8. So I am typing this out in the chat, as you can see. So this is why it is possible for that first list to have been only sorted with 2 passes of bubble sort. So for the second list, it could be sorted with 2 passes of bubble sort because as you can see, the largest and second largest values are at the end again. So a possible scenario where possible list this could have started with if you only want to get that result using 2 passes of bubble sort are let's see. Okay, so I'm thinking that suppose we start off with the list 6, 5, 2, 1, 3, and 4. So after the first swap of bubble sort, the first pass of bubble sort, we would have 6 at the very end. So then we have the list 5, 2, 1, 3, 4, and then 6. And then after the second pass of bubble sort, we would have the list 2, 1, 3, 4, 5, and 6. So that's the reason why bubble sort is possible for this second list over here. And then for the last list, bubble sort is also possible because as you can see, the largest and second largest values are sorted correctly again. So to think of a list that we could have started with in order to end up with this result for 2 passes of bubble sort, we could have started off with the list one, let me think, 1, 3. We could have started off with the list 1, 3, 5, 5, 6, 4. So after the first swap of bubble sort, we would end up with the list 1, 3, 5, 5, 4, and then 6. And then after the second pass of bubble sort, we would end up with the list 1, 3, 3, 5, 5, 5, no, 1, 3, 5, 4, 5, 6. So this is why 2 passes of bubble sort are like possible in order to get that result. So the seminar is mostly over. Thank you guys who have stayed for the entire thing. I put these links for useful study resources. So I have the link for the test 1 review seminar material. The test 2. All right, I'll respond to that question in the chat after I'm done explaining the slide, but test to review seminar material. I put the Piazza link for that, and then the old exam library. I have the link for that, and then I have the W3 school summary of the Python documentation. If you really want like a really quick summary of the Python documentation, if you just click on it, it could be helpful if you just need to review like a few more things like string methods or list methods. It would just give you like an entire table of all the methods that you could use on a string. So, and then you can click on the method, for example, lower, and then it will show like what parameters it can take and how to use it properly, the syntax for it. And that is it for my presentation. Thank you for your participation. I wish you guys the best of luck on your exam tomorrow. I will be posting this recording once it's done formatting and downloading, and I will be editing a lot of the mistakes that were on these slides. You guys did a really good job and really helpful, like pointing out these mistakes. I'm really thankful for that. Thank you. So there's a question saying with excess, with the question 4 from my examples, they were asking why excess, slicing from 4 all the way to -5 going to 1 can get 4, but when you go backwards, it gets the empty string. So the difference between going forwards and going backwards is that the 5th last index is index 5, and it gets the string containing 4 because the indexing starts at index 4, which contains the number 4, and it goes, and it does not include the 5th last index, so you would get the number 4. But then when you go backwards, it gets the empty string because the 5th last index is index 5, but index 5 is larger than index 4, so you cannot really go backwards. You can only go forwards because index 4 is smaller than index 5, and in order to go backwards, you have to start with a larger index and finish with a smaller one. So that's why it's empty. Does that answer your question? No, it shouldn't be going backwards because we want to start with the larger index and not like finish with it. So like the start index in the slice is 4 because, and the end index is 5 because you remember it's start, end, and then the step when you slice, right? So you want to start, if you want to go backwards, then you would need start to be bigger than end in order for you to be able to go backwards. But then since start is 4 and then end is 5, is -5, which is basically 5, then going backwards will not work. Because 4 is less than 5, but we need start bigger than end or backwards. Yeah, does that answer the question better? All right, are there any more questions? No problem. Okay, I'll end the presentation now. Hope you guys. I wish you guys the best of luck on this exam because I hear that you guys from the chat, like, this class is really hard. So if you guys still have questions, you guys can like go to the announcement where I posted the post where I posted the announcement of the seminar and just ask the questions there, and I'll try to answer it between now and tomorrow at 1 p.m. So yeah, I'll end the seminar and the recording. Thank you guys so much for your hard work and participation, and I wish you the best of luck for tomorrow. Goodbye.